Hi, welcome to my video. Now in this video, we're gonna do electrochemistry. Electrochemistry is one of the simplest concept here in physics. It's simple only if you focus, okay? It will get much more simpler when you focus. So there is actually nothing difficult about this, but most definitely we're gonna start with the introduction. We're gonna learn some concepts that we need to understand firstly before we can move forward with this topic. So now here we have the definitions of what is electrochemistry. It's very important to start with a definition before we can embark on the concept. So now the whole concept itself, or the word electrochemistry, it is explanatory. Electro means electricity, and then chemistry simply means chemistry. So now here, the part of chemistry, we are most definitely going to talk about the reactions, okay? And then here, electro, we are most definitely going to talk about the electricity. Now we say electrochemistry is a branch of chemistry that deals with the study of the relationship between electricity and chemical reactions, okay? So now when it gets to electrochemistry, this is what I want you to understand. Each and every time when you hear a word or when you hear a term, electrochemistry, think of two things, electricity and chemical reactions. Now, there are two types of cells that we are going to talk about under electrochemistry. It is called the galvanic cell or voltaic cell. And another type of a cell, it is called the electrolytic cell. So one of the two cells, which is I'm not going to discuss with you right now, one of the two cells, the other one, it is using electrical energy to form chemical energy. And the other one, it is using the chemical energy to form the electrical energy, meaning we are talking about vice versa. So there are two types of cells that we are going to learn in this unit. So now, since this is what you call the electrochemistry, what is the importance of electrochemistry? The electrochemistry, like I said, it's all about the conversion of energy, okay? So remember, I said to you, amongst the two cells, there is one at which chemical energy is going to be converted into electrical energy and the vice versa, meaning there is a one at which electrical energy is going to be converted back into chemical energy. So now, since this is the whole process that will be taking place in one of the cells that I have just mentioned, which is galvanic or electrolytic cell. So now, what are the examples of these cells? Okay, so where can we see these cells? We're gonna do those cells under the concept of understanding how does electrochemistry work, but actually where do we see these cells? We use the batteries. Batteries is one of the examples of the cells. We know that with batteries we use chemical reactions. A battery has chemicals inside of it. Those chemicals inside of it, they convert those chemicals inside of it, they will undergo chemical reaction. And that chemical reaction in the form of energy, which is chemical energy, will now then be converted into electrical energy. And therefore, we know that a battery, it is a source of power that can power an electronic device. Okay. And then another example of electrochemistry, electrochemical process, it is corrosion prevention. For an example, we know that we have the pots that they call stainless steel. Those examples of pots, they were prevented by using corrosion prevention. When they say something, it is stainless, meaning it doesn't form stains, it doesn't undergo oxidation to form a rust. So meaning in chemical industries, what they do is there is a process which they do for corrosion prevention. They coat maybe your metal, which could be a pot or the cutlery or whatever. They coat them with certain metal that will prevent that will prevent corrosion. Okay. Another electrochemical process, it is electroplating. Okay, electroplating. For example, we have gold rings, right? We have silver rings, like rings for marriage. So what they do in some other industries, they plate those rings with maybe they take a copper and then they plate it with silver, and therefore now the ring looks silver. Okay, so that's what they do. And then we have the fuel cells. The fuel cells, what is happening is in these fuel cells, meaning they use fuel to form electricity. So meaning fuels are the chemicals. So those chemicals, they undergo reaction, and that reaction will yield into a chemical energy, and that chemical energy will therefore be able to convert electricity in a form of electrical energy. Okay, so these are just few examples of electrochemical processes. Okay, remember these electrochemical processes, they use a concept of what you call electrochemistry. Okay, and I hope that was clear. Right, so now in this slide we have the key concepts that we need to understand. Okay, like I said, before we can embark on this concept, we need to understand some few terms. Now we have what you call the redox reactions. Okay, and redox reactions, this type of reactions, we have dealt with them in grade 11. So when you talk about the redox reactions, we are talking about the reduction oxidation reactions. Now, these type of reactions, we say they are electrochemistry based. Okay, now what is these types of reactions? It's whereby one species loses electrons and another species gains the electrons. Now, what you see over here, this is what is happening. It's this reaction, it involves the transfer of the electrons, right? Now here we have two reactants that are going to interact with one another, right? We have reactant A and reactant B. Now remember, like I said, there are different types of reactions, but this one, it is a specific one, which is called the redox. We can have acid and base, we can have whatever, but here it's redox reactions. Now, when this species sees this species, this is what is going to happen. Say, for example, amongst the two, the other one's supposed to be weak in losing the electrons. The other one's supposed to be strong in losing the electron. Okay, the other one's supposed to be weak in gaining electron, the other one's supposed to be strong in what did I say? Weak losing electron, strong losing electron, or weak gaining electron, or strong gaining electron. Okay, they must be like that. So now this is what is happening in this case. A, it is the one that is going to lose electron, meaning A, it is strong at losing electron. That means B, it is weak at losing electron when it interacts with A. Okay, so for the fact that the B, it is weak at losing electron, that means it is strong at gaining electron when it interacts with A. So that means in this case, A will lose electron and B will accept that electron. But now this is what we want to understand. If this reaction takes place, what is going to happen with this species, which is species A? Meaning when A loses the electron to B, therefore A will say it will be oxidized, meaning A will undergo oxidation. How so? Now, from 0 to positive number, we are talking about an increase in oxidation number. Our oxidation number over here, our oxidation number over here, it's 0, and our oxidation number over here, it's positive, meaning from 0 to positive, that's an increase. So meaning if your oxidation number increases, we are talking about oxidation. So that means species A will undergo oxidation. But now, why is species A undergoing the oxidation? Because species A, it is losing the electron. So when it loses the electron, therefore its oxidation number will increase by number of electrons it has lost. Okay, that's A. Now, because B, it is weak at losing electron or electrons, that means B, it is strong at gaining electron or electrons, because here it is gaining when it interacts with A, most definitely, because B can change. So now when B gains the electron, we'll say B will undergo the reduction. Okay, now what is happening with the oxidation number of B after it has reacted with A, you see, B to B, we want to see after what's going to happen with B. Now, the oxidation number of B before interaction was 0, but after an interaction with A, the oxidation number of B now it is negative. So what does that negative mean? Meaning this negative, it indicates that the oxidation number has decreased from 0 to negative. It has decreased. So meaning when you talk about the decrease in oxidation number, what are we talking about? We are talking about the reduction. When oxidation number decreases, we are talking about the reduction. So that means B, it is undergoing reduction since, well, it is gaining the electrons. But now, how do we see that B has underwent the reduction? Because its oxidation number has decreased. Okay? That's how we can see this type of reactions, which is called the redox reactions. Remember, it is one species whereby it is going to lose the electron, and the other species it is going to gain the electrons, meaning one species will undergo oxidation, one species will undergo reduction. So hence why we call them the redox reactions. And remember, in redox reactions, we are talking about the transfer of electrons between the species that are interacting with one another. Okay, that's how we define explain redox reaction. Right. So now here we have an example of a redox reaction. Okay, this is an example of a redox reaction. Now this example of redox reaction, it is the same as what I have just explained, just that here we are using the real compounds or molecules. Okay, this is an atom and this is a molecule of oxygen. So now this is what is happening when ion Fe, when ion reacts with oxygen, this will be a product that is going to be formed. Okay, now this is what is happening when you have a look at this reaction. What happened with Fe? We are focusing on Fe. What happened with Fe? We say its oxidation number has increased. The oxidation number of Fe from grade 11, you're supposed to know these things. Remember, there are certain rules that we assign for the oxidation numbers. So now you're in grade 12. That means we're just going to assign these oxidation numbers without going through the rules because we know them. Okay? So now in this case, the oxidation number of Fe is supposed to be 0. And the oxidation number of Fe after it has interacted with oxygen, remember here is going to be 2 plus, right? And therefore, let's talk about the oxidation number of oxygen. Now from here to here, what happened with the oxidation number? Remember, it is stable as it is, it's going to be 0. And then there it's going to be how much? It's going to be 2 minus. So now let's go back to Fe. What happened with the oxidation number of Fe? The oxidation number of Fe from 0 to positive 2 has increased. That means we say Fe, since well oxidation number has increased, we say Fe will undergo oxidation. But oxygen from 0 to negative 2, what happened with the oxidation number? The oxidation number has decreased. When oxidation number decrease, we say now our species, it has underwent a reduction. Okay, so again, this example, it is what I have just explained above there, just that here we are using the real chemicals. There I was just using an analogy of A and B compounds. Right, so that's how we see the redox reactions. A quick reminder on what you did in grade 11. Now, number 2, it says electrochemical cells. Now, what is electrochemical cells? Remember, I said to you, this module or this concept, it is called electrochemistry. Now, in electrochemistry, I mentioned two types of cells, okay? I mentioned two types of cells, which is electrolytic cell and galvanic cell. So when you talk about the electrochemical cells, this is what we are basically talking about, okay? This is what we are talking about, 1, 2, electrolytic cell and galvanic cell, okay? These are the devices that convert energy from one form to the another form. Remember what energy? We're talking about the chemical energy. We are also talking about the electrical energy. But you have to know between the two, from chemical to electrical, it is this one or it is that one. Now, electrolytic cell, you can see that we have electrical source. That means here we're going to take electricity, and this electricity, we're going to use it to form a chemical reaction to take place in this solution. So that means here we are talking about the conversion of electrical energy into chemical energy. Okay, that's an electrolytic cell. Okay, electrical energy to chemical energy. But when you talk about the galvanic cell, what are we actually talking about? The galvanic cell, it's what type of energy conversion, meaning these chemicals is like a battery, okay? The battery that you know, a small form of power. So galvanic cell, these chemical reactions that are present in these two beakers, these chemical reactions, they will be in a form of chemical energy. And these chemical energies will be converted into electrical energy, meaning here we want to form electricity, just like a battery, right? A battery can form electricity, meaning the chemicals inside of it, they form electricity, okay? So these are the electrochemical cells, but this is a specific one, which is called the electrolytic cell, and this is called the galvanic cell. And here we are talking about the conversion of which energy? Electrical energy to chemical energy. And then here, what type of conversion of energy are we talking about? We are talking about chemical energy to electrical energy, vice versa with this one, okay? And you know what? I want you to pay attention. I want you to pay note. I want you to take note of these two devices, okay? They are different. You can see here we have only one beaker, and then our electrodes are in one solution, which is called an electrolyte solution. And then we have a source of power here, okay? By noting all of these things, you can just look at the differences between this and that. I mean, like number one, the process is taking place in one solution. I mean, like you see here, number two, galvanic cell, there are different solutions basically, okay? But these are also electrolyte solutions, okay? And therefore, we have the salt bridge, there is no salt bridge. We have electric source, there is no electric source. You see, you can also note the differences and similarities. Similarities, we use electrolyte solutions, you understand? Even though they are different, we use the electrodes, okay? But it's fine. We'll get deeper when we do electrolytic cell and galvanic cell individually. Right. Now, another definition, electrolyte. So now what is an electrolyte? Electrolyte, it is simply a solution that can conduct electricity. That's what we call an electrolyte. A solution or a substance that can conduct electricity when it is dissolved in water. Okay? But normally we say electrolyte, it is a solution, okay? Like when I go back to this figure right here, they say this is an electrolyte solution. This is an electrolyte solution, meaning this solution can conduct an electricity, okay? When we're talking about the electrolyte solution, it is a solution that can conduct electricity with those ions in it, positive and negative ions. But you will see again, how do we draw these solutions as we continue with these things. I'll show you. Okay, so that's an electrolyte. So now there are certain common types of electrolytes. We have the acids, the bases, and the salts, okay? So meaning if you take one of these solutions, they are regarded to be electrolyte. They will dissolve in water and form what? And form positive and negative ions in water. Now we have what you call the electrode potentials. Okay, so the electrode potentials measure the tendency of an electrode to gain or to lose the electrons. And therefore, to determine this, we use the potential difference table. Okay, let me show you what am I talking about. This is the table that I'm talking about, the standard reduction potentials. We use this to determine the differences of what? Of electrode potentials. So what you see over here, we say, what is electrode potential? Electrode potential measure the tendency of an electrode to gain or to lose the electrons. You will see this again when I do an explanation within the electrolytic cell and the galvanic cell. Now we have the electrolysis. So now what is electrolysis? The electrolysis, it is the process of converting what? It is the process of using electric current to drive a non-spontaneous chemical reaction. So electrolysis, it is a process that is taking place in electrolytic cell. Okay? Electrolysis, it is a process that is basically taking place in an electrolytic cell, meaning it is the process of using electric current to drive a non-spontaneous chemical reaction. I will tell you when we talk about the non-spontaneous, what are we talking about? Okay, we have spontaneous chemical reaction and non-spontaneous chemical reaction. Spontaneous, it is a type of reaction that is taking place without it being forced. But this, what is taking place in electrolytic cell, we're gonna force that to happen. I'll show you. I'll tell you what do I mean when I say that. Okay, and then electrolysis, which is the process, it is commonly used for electroplating, metal extraction, and water splitting. Okay. All right. So now this is what I want to do. Okay, so these are the definitions. Make sure that you familiarize yourself with these definitions, and that's it. So now this is what now I want to do. Okay, now I'm going to talk about the galvanic cell, everything about galvanic cell. Okay, so we're gonna do galvanic cell. Okay, galvanic cell, or you can say it is called voltaic cell. Okay, so now remember, what did I say to you? I said galvanic cell, it is a type of a device that converts chemical, that converts a chemical energy to electrical energy, this device, which is called the galvanic cell. Okay, so now let us reconstruct our own galvanic cell and explain it. Okay, all right, so now let's set up our galvanic cell. Okay, now we have what we call a beaker. Okay, we have a beaker over here. Let me open it. We have a beaker over here, and then we have another beaker over here. Okay, we have another beaker over here. These are two beakers. In this beaker, we're gonna have a solution in this beaker. Oops. In this beaker, say we have a solution in this beaker. Okay, same applies to that beaker. Say in that beaker as well, we have a solution. But now, what solution do we have in this beaker? We're gonna have copper sulfate. Okay, in this beaker we have a solution. Okay, the solution is a solution of copper sulfate. So now we know that in this beaker, since we have a solution of copper sulfate, it is an ionic compound. Now this ionic compound will dissociate into its ions in this solution. So that means this solution will composed of Cu2 plus ion, this is copper 2, and then another ions from the solution of copper sulfate, we're gonna have these ions, SO4 2 minus ions. We're gonna have many tons and tons of these ions in this solution. Okay, now let's go back to that solution. say in this solution, we have, let me go for zinc sulfate. So say here we have zinc sulfate. In this solution, this is an ionic compound. It will dissociate into its ions. So that means in this solution, we're going to have zinc 2 plus, and therefore we're going to have SO4 2 minus once more again in this solution, right? Right. Now, in this solution of zinc sulfate, because we want to set up a voltaic cell, remember, this is a chemical, right? This is also a chemical. So we want this reactant to interact with this reactant, meaning zinc sulfate, we're going to make it to react with copper sulfate, but you'll see how. So in order for us to join these two solutions, we're going to use the electrodes, okay? First, we're going to insert our electrode in this solution. But the electrode that we're going to insert is supposed to match with this solution. So that means in this beaker, we're going to insert an electrode of zinc, which is a metal electrode, okay? Remember, I didn't say cathode or anode. I just said electrode for now. Okay, we are setting up our galvanic cell. Now, in that solution, in this solution that has copper sulfate, I'm also going to immerse my what? My electrode inside of it. But this electrode, okay, supposed to match the solution as well. That means I'm going to insert my metal copper electrode. Okay? Now, sharp fine. Now I want to link these two half cells. We call them the half cells. Remember, this is an electrolytic, it's a galvanic cell. So it's a full galvanic cell when it is joined together to form one thing. But this is half cell of copper of zinc, half cell of copper. Now let's try to link up these two cells. Okay, so we're gonna link up these two cells by a good conductor of electricity, which is a wire, okay, which is a wire. Now we have joined these two cells, okay? Right. Now this is what is happening. When we join these two cells, remember it is galvanic cell. And when we talk about the galvanic cell, we say chemical energy gets to be converted into electrical energy. But now, where is chemical energy that we are talking about? So now the chemical energy that we are talking about is within these two half cells. Like I said, this supposed to react with this to produce electricity. But where is that electricity going to travel? That electricity is supposed to travel on this wire over here. Okay, so that means how are we going to tell, or how are we going to be able to tell whether there is a presence of electricity in this wire? You can use any device. You can use galvanometer, you can use your multimeter, or you can use your light bulb. Say for an example, I choose to use my light bulb over here. So that means I choose to use my light bulb over there. If I choose to use my light bulb over here, if there is a presence of electricity in this galvanic cell, therefore this light bulb will start to do what? Will start to shine, to glow. Okay. But this electrolytic cell, it can take place in this way, but at some point it's gonna stop. Why? Because there is a missing portion over here which we call a salt bridge. Okay, salt bridge, it maintains the neutrality, it maintains the balance within these half cells. Because if there was no salt bridge over here, this reaction was going to take place very quick, and therefore this will even burn faster. So now this is what we need to do, meaning we're going to include what we call the salt bridge. Okay, we're going to include what we call the salt bridge over here. This is what we call the salt bridge. Okay, we include our salt bridge over here to join again this, so that this can be 100% complete our electrolytic cell. Now salt bridge over here we have cottons. We're gonna include our cottons. We're gonna stuff a cotton over there. We're also gonna stuff a cotton over there. But what's the purpose of us stuffing a cotton over here? Because salt bridge Okay, salt bridge has a solution which you call a sodium chloride. It could be any solution as long as this solution it is ionic compound. Okay, I'll tell you why. So it's a solution in this side of salt bridge. So we stuff cotton here so that these ions do not get discarded in one of these two half cells. Okay, we're just protecting these ions not to get into these solutions, to mix up with these solutions. Okay, right. So now let us explain deeper then. Now we completed our galvanic cell. Now this is what is happening. Let us learn about it. Now, before we can understand which is cathode, which is anode, and all of that, this is galvanic cell, right? This table, it is a standard reduction potentials. It's a table of standard reduction potentials. This table, it satisfies everything that says galvanic cell. This table, it talks about everything that says galvanic cell. I'm telling you now. But this table, it actually opposes everything that says electrolytic cell. I'll tell you later on when we do electrolytic cell, how does this table actually opposes electrolytic cell? Right now, let's just talk about how does it satisfies electrolytic cell. Okay, this table it satisfies not electrolytic galvanic. Okay, it satisfies galvanic cell. It satisfies, or just know that. Okay, it satisfies galvanic cell. But how? This is how. Let me show you something. Now, in this half cells, okay, we do not know. Remember, I said to you, this this device, the reaction that is going to take place, interaction of this and this, the reaction that is going to take place between these two, it is called what? It is called the redox reaction. Okay. Now, meaning we have zinc, we have copper. But the problem is, let's say we do not know between the two which one will undergo oxidation, which one will undergo the reduction. You can start from the scratch by doing your reaction, blah, 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 you will see. But let's say for now, we do not know which one is, which one will go under, which one will go reduction, which one will go oxidation between these two. So now I'm going to use my table because I'm talking about galvanic cell. I say this table, it satisfies galvanic cell. I'm going to use my table between zinc and copper. I want to determine which one will undergo oxidation, which one will undergo reduction. So in my table, I'm going to look for copper 2. Okay, copper 2, not copper 1. Copper 2. Here is copper 2. Here is copper 2. Okay, here is copper 2. And therefore, I'm going to look for my zinc once more again. And then my zinc supposed to be somewhere else. Here is my zinc. Okay. Now, I prefer to use this arrow. It's fine if you use this arrow. It's fine, but I prefer to use this arrow. Now, I'm going to use this arrow. What does this arrow say? Remember, this table satisfies galvanic cell. What does this arrow say? It says moving upwards of this table, we have increasing oxidizing ability. You know what? I don't like this statement because it's a little bit confusing. Increasing oxidizing ability. So something that causes something to undergo oxidation, we say it has that ability to cause something to undergo oxidation. Meaning, what you get above compared to what you get below, this, it has a greater strength in increasing oxidizing ability. Like I said, I like to change the statement. What I like to do, I like to say reduction. Because the one that causes something to undergo oxidation, meaning itself, it undergoes reduction. So this is what I like to do. I like to say reduction. Up the table, if I move up the table, it's reduction. Below the table, it is oxidation, but I will just use only one arrow. So now what do I mean when I say this? That means moving upward, you will get your reduction. So meaning something which is above, it is the best reduction over something which is below. I mean, like for an example, take, let me change my pen. take silver and take this copper. Take silver and take this copper. Silver is above, meaning it will undergo reduction. Because when you go up the table, everything that you get above will undergo reduction. If silver undergoes reduction, that means copper will undergo what? Oxidation. Okay? Now, this is what is happening. Remember, we are actually talking about copper and zinc. We want to determine between the two, which one will undergo oxidation, which one will undergo the reduction. So that means moving up the table, what you get above is reduction. So that means copper will undergo reduction. And therefore zinc, that means will undergo oxidation. Simple as that. This table satisfies galvanic cell. It makes sense for galvanic cell. And so I'm saying this table satisfies galvanic cell with what I just did right now. So that means, oh, copper will undergo reduction and zinc will undergo oxidation. I'm going back. Now, in these half cells, now we know that zinc will undergo what? Oxidation. And then copper will undergo what? The reduction. Okay? All right. Now, in this case, we have what you call red cat. We have what you call oil rig. We have what we call red cat. It undergoes with an ox. Okay? So now, this is what is happening. We want to determine the electrode of zinc. We want to determine whether a zinc will undergo oxidation or reduction. We have already done that using our table that zinc will undergo oxidation. So oxidation takes place at an electrode which is called an anode, an ox. That means this electrode, this zinc electrode, it is called anode. Okay? Now, red cat reduction is taking place at cathode. We said copper will undergo reduction. How did we determine copper is undergoing reduction? We used that table. That means copper, this metal, this electrode, it is called cathode. It is called cathode. Okay? Now, we know that oxidation is losing the electrons, right? That means zinc supposed to lose the electrons.